Hey guys, it's Mr. Whalen, and we're going to cover topic 1.2, which is terrestrial or land-based biomes. So our learning objective for this section is to describe the global distribution and principal environmental aspects of terrestrial biomes. We're going to look at the components of a biome and how they're adapted to certain climates. We're going to look at the major categories of biomes and look how they're distributed across the globe due to latitude. And we're going to look at how they are not statically defined, that they can change over time based on climate change. What's a biome? It's an area that shares a combination of average yearly temperature and precipitation. So remember that climate and weather are two different things. Climate is a year-long, big picture system based on average yearly temperature and precipitation. Weather can change day to day. Climate changes, but over time, slowly with trends. Some examples that you're probably familiar with of biomes: you've got the rainforest, which is going to be super wet and warm. The taiga, temperature deciduous forest, grasslands, desert, tundra. The desert is going to be really warm, but very low precipitation, whereas the rainforest is going to have a lot of precipitation. Our big picture thinking like a mountain idea about biomes is that they are a community of organisms, plants and animals, in a biome that are uniquely adapted to live in that place. All right. So, for example, camels and cacti have traits that help them preserve water. Camels withhold water in their hump. Cacti have these waxy coatings so that they aren't losing too much water. Shrubs and wildflowers store lots of energy in the roots to recover quickly from fire in grassland. So camels and cacti live in a desert. Shrubs and wildflowers live in a grassland. Based on the qualities that you see in these spots around the globe, the living things there are going to adapt really well to those particular qualities. So if we look at this chart, and this is in your textbook, I believe, flipped around actually. You can see temperature and precipitation charted against one another, and it shows you where those certain biomes fall in that chart. Again, we're defining it by an average temperature and precipitation over time. So you can see that the tundra is got very low temperatures and very low precipitation. Over here where it's warmer, all right, keep in mind this is Celsius, the desert is down here with higher temperatures but low precipitation, the rainforest here, and then the savanna or tropical seasonal forest is going to be in the middle here. All right. So based on this chart and based on knowing an average temperature and an average amount of precipitation, you can kind of predict what kinds of biomes you're going to find in what spots. All right. So if you look at a map, you'll notice that regardless of continent, the same types of biomes fall on the same latitudes. All right. Up the top here, all right, at the higher latitudes, you're going to have the tundra, all right, which really cold and low precipitation. All right, and the middle areas here where we live, all right, you've got more temperate climates. And so you've got temperate seasonal forest, temperate rainforest. All right. And then as you get towards the equator, you have these more tropical type biomes, the rainforests, the savannas, and the deserts. All right. So tundra and boreal are at 60 degrees latitude. Temperate is in the middle latitudes, and tropical is going to be close to the equator. All right, our big picture idea is to keep in mind that latitude, which is the distance from the equator, okay? And that is going to determine temperature. It's going to be warmest at the equator, coldest furthest away from it, and it's also going to predict how much average yearly precipitation those areas are going to get as well. Nutrient availability is a really important concept within biomes as well. Plants can't grow without nutrients. So depending how many nutrients are available, regardless of where the biome is latitudinally, plants may adapt well, or they may change, like in deserts. So for example, in the tundra, you've got frozen soil in the tundra, and it doesn't allow for nutrient absorption from dead organic matter. And so you've got really low soil nutrients, low water availability. Not many plants are going to survive in the tundra. Here you have this ice wedge. You can see within the tundra, the active layer is right up top here, and then you've got all this permafrost, okay? And it's going to freeze and melt each year, but the quality of that soil is pretty low, and you don't get a lot of plant life, right? Here's a picture of the tundra with a lot of just low-lying shrubs. The tropical rainforest, counterintuitive. You think of tropical rainforest has a lot of plants. It does, but they're all competing. So if you go back to section 1, competition, it hurts both things that are fighting for that resource. And in tropical rainforest, it's nutrient poor soil because everything's fighting over everything else. In a boreal forest, you also have nutrient poor soil. It's a low temperature, and then there's a low decomposition rate of dead organic matter. In a temperate forest, where we live, much more nutrient rich soil, lots of dead organic matter. Think about what we're going to be seeing soon. I'm recording this on September 15th, but in the next month, you're going to have leaves falling all over the place. All of those leaves are going to decay and add some rich nutrients back into the soil. So biomes are not static. They can change, all right? They can shift in location on the Earth as the climate changes. So warming climates can shift boreal forests further north, and the tundra permafrost soil will melt as it gets warmer. And the lower latitudes will basically be, will accommodate bigger trees that couldn't grow in the tundra. So if you look at these two pictures, this is 1971 to 2000, and this is the year 2071 to 2100. Now, the year 2071 is a little far off. It'll be probably the year that you guys are retiring, hopefully. But look at the shift north of these temperatures and the predicted, based on emissions, the predicted shift north of this plant life and the biome. This is an actual photograph, and you can see looking north, all right, that right here you have few trees, okay? It's much colder here, all right, 1962. It is warmed, and now it's the same spot. You have much more tree growth in this area as it has gotten warmer in more northern latitudes. So our free response question is going to focus on the skill of explaining environmental concepts and processes. And for this free response question, I want you to identify one characteristic of a biome and explain how that characteristic determines the community of organisms found in the biome.